My dear students, I am going to teach you the third part of the 10th class. This is a most important part of this class. In this part, you have to prove that irrational numbers, and for this, we have to assume a contrary to the given. So, this is a very important part, and you will get one question 100% in annual examination of 10th class. So you have to take it very seriously. I will take 2 or 3 examples of this type, and listen to me very carefully and see the example on the board very carefully so that you can find out this question very easily. So I'm going to discuss, I'm going to explain the detail of these questions, and I will going to take one example of a irrational number. How will you prove that this is a irrational number? Prove that root 2 is a rational number. Yeah, this is first example. Prove that root 2 is a rational number. You have to prove root 2 is a rational number. For this, let root 2 is a, we have to prove that root 2 is a irrational. But we have to assume, contrary to what is given, root 2 is a rational. These questions can be solved by taking or by uh, opposite to the given. And we have to let opposite to the given. We have to prove that root 2 is a rational number. But we have to assume that root 2 is a rational number. If the condition of rationals are not satisfied, then automatically it will be irrational number. This is the condition. So root 2 is a rational number. We assume root 2 is a rational number. But according to definition, P upon Q is also rational number, because rational number can be expressed in the form of P upon Q. So root 2 is a rational number, P upon Q is also rational number. By comparing first and second, we get P upon Q is equal to root 2. And next, by squaring on both sides, by squaring on both sides, by squaring on both sides, P square upon Q square is equal to 2. By cross multiplication, by cross multiplication, by cross multiplication, we get P square is equal to 2Q square. This implies that P square is divisible by, P square is divisible by 2 according to theorem. According to theorem. This implies P is also divisible by divisible by 2. Divisible by 2 and divisible by 2. So here you see that P is divisible by 2. One thing we have proved. Now I am going to prove that Q is also divisible by 2. Listen, see here carefully. Taking P, we can write P we can write P is equal to 2m, where m is an integer. Because why this can be written? Because P is a multiple of 2. P can divide 2. So this P can be written into 2 into m. And by squaring, P square is equal to 4m square. And by putting the value of P square in in P square is equal to 2q square. Four m square is equal to 2q square. 2q square is equal to 4m square. Q square is equal to m square, 2m square. So this implies q square is divisible by 2. Q square is divisible by 2 according to theorem. According to theorem. This implies q is also divisible by 2. So we have proved here. Note it here. The main point is P is divisible by 2. Q is also divisible by 2. But P and Q, according to the definition of rational number, P and Q are co-prime number, have no common factor other than 1. And here you see these two, P and Q, have two common factors, which is contrary to the statement. Therefore, P and Q are divisible by 2, are divisible by 2. We have proved. We have proved. But this is against the definition of, against the definition, against the definition of rational number. Definition of rational number, in which P and Q are co-prime number, have no common factor, have no common factor other than 1, other than 1, have no common factor other than 1. So this is contrary. So our assumption, our assumption, so our assumption was wrong. Our assumption was wrong. Hence, root 2 is a irrational number. Irrational number. Root 2 is a irrational number. This is the proof of root 2 is a irrational number. This question is a very important question. Now I'm going to take one more example. Root 3 is also a irrational number. Root 3. prove that root 3 is a irrational number. Irrational number. Let root 3 is rational, but P upon Q is rational. According to definition, a first, a second. Compare first and second. P upon Q is equal to root 3. By squaring P square, by squaring on both sides, P square upon Q square is equal to 3. This implies P square is equal to 3Q square. P square is equal to 3Q square. This implies P is divisible by, P square is divisible by 3 according to theorem. This implies P is also divisible by 3. Now P can be written. So P can be written in this form. P is equal to 3m. M is an integer. P square is equal to 9m square. By putting the value of P square in P square is equal to 3Q square. Three Q square. P square is 3Q square in P is equal to 3Q square is equal to 9m square. Q square is equal to 3m square. This implies Q is divisible by 3. This implies Q square is divisible by 3. Q is divisible by 3. Hence, here P is divisible by 3 and Q is also divisible by 3. It means P and Q have a common factor 3, other than 1. This is against the this is against the definition of rational numbers, because P and Q are co-prime numbers. Co-prime numbers. Co-prime numbers. P and Q are co-prime numbers. So our assumption, so our assumption was wrong. Our assumption was wrong. Hence, root 3 is a irrational number. These questions are very important from the examination point of view, or the terminal examination or internal examination of half yearly or other type of examination of the school. So this was the third part of the first chapter. This third part is the most important part of this chapter. You will get 100% one question in annual examination, in board examination. So I have already told you that I am teaching you for the knowledge as well as marks point of view, because marks are very essential for your academic career. So in all the chapters, I will teach you ninth class, 10th class, 11th class and 12th class mathematics, and I will give you the important question in every chapter, in every part. You have to take note of that question. If you will take seriously, you will get 100% marks in mathematics. Thank you.